In this video, we will look at the mechanism for migratory insertion reactions. These are reactions that take place between carbon monoxide and metal hydrides, as shown in the note card here, where we form a new metal carbon bond, shown here, as well as a new bond between the carbonyl carbon and the hydrogen that used to be the hydride on the metal hydride complex. If we look at the complex formed from association of the carbonyl ligand to the metal hydride complex, that gives us the structure shown here. And if we take a look at this, this looks very similar to other carbonyl-based electrophiles, where now we have a carbon-oxygen with a dipole set up. That tells us that the carbonyl carbon is going to be electrophilic. And what we need to look at is, do we have a nucleophile nearby? And it turns out that the metal hydride, or rather the hydride bound to the metal, is going to be our nucleophile. And so we can simply draw it adding to the carbonyl carbon, breaking one of the pi bonds, and now forming a carbon-hydrogen bond as opposed to a metal hydride bond. This is called a 1-1 insertion because the hydride ligand attached to the metal ends up on the first atom, or the atom attached directly to the metal. To walk through this mechanism a little more completely, what we want to do is start out by drawing our Lewis structure for carbon monoxide. And we want to make sure that when we do this, that we draw in our formal charges. So what we notice when we look at the Lewis structure is that the carbonyl carbon, or the carbon monoxide carbon, is not very electrophilic. In fact, being full anionically charged, as shown by the formal charge, that's going to be pushing away any incoming nucleophiles. And so through the process of association, we can draw the metal hydride complex. We've relieved the carbon of its negative charge by sharing electrons with the metal, setting up now to act as an electrophile. So the metal hydride can take its pair of electrons and add to the carbonyl carbon and displace those electrons in the pi bond, going from a triple bond to a double bond. And we can see those electrons show up on our Lewis structure here of now an aldehyde ligand attached to the metal. It's important to note that this general mechanism applies for both metal hydrides as illustrated here, but also alkyl groups. So we can see a methyl group or a ethyl group transfer from the metal to the carbonyl group.